Welcome to a bold new frontier in the quest for interplanetary colonization. Imagine transforming the harsh, uninhabitable surfaces of planets similar to Mars into lush, life-sustaining worlds. This is the concept of planetary terraforming. At the heart of this speculative approach lies an astonishing idea: using controlled thermonuclear explosions to kickstart the transformation process. These powerful detonations could release trapped gases, trigger chemical reactions, and ultimately create more habitable environments. Join us as we embark on a journey through time and space, envisioning a future where humanity extends its reach beyond Earth, transforming distant worlds into thriving habitats. Welcome to Thermonuclear Planetary Terraforming. To truly understand the potential of planetary terraforming, we must first grasp what it entails. Terraforming is the process of transforming a planet's environment to make it more Earth-like and capable of supporting human life. This ambitious endeavor is of immense interest to scientists and space enthusiasts alike. It holds the promise of expanding humanity's footprint beyond Earth, ensuring our survival and opening new frontiers for exploration and settlement. Take planets like Mars, for example. These worlds present a myriad of challenges. Their current conditions include thin atmospheres, low temperatures, and surfaces bombarded by radiation, all of which make human colonization incredibly difficult. To make these planets habitable, we must alter their atmospheres and surface conditions. This involves increasing atmospheric pressure, raising temperatures, and potentially creating magnetic fields to shield against cosmic and solar radiation. The necessity of these changes is paramount. By thickening the atmosphere, we can trap more heat and create a stable environment where liquid water can exist. This is crucial for supporting plant life, which in turn produces oxygen, creating a breathable atmosphere. At first glance, using thermonuclear explosions as a tool to transform barren worlds might seem radical. However, controlled thermonuclear detonations hold the potential to dramatically alter a planet's environment, paving the way for habitability. Many planets like Mars have vast amounts of trapped gases and water vapor beneath their surfaces, resources that are crucial for creating a thicker, more Earth-like atmosphere. By strategically placing and detonating thermonuclear devices, we can generate immense heat and pressure. These controlled explosions would release trapped carbon dioxide and water vapor from the subsurface layers. As these gases rise to the surface, they would thicken the atmosphere, increasing the planet's temperature through a greenhouse effect. This warming could eventually lead to the formation of liquid water, a key ingredient for sustaining life, and set the stage for further terraforming efforts. The energy from a thermonuclear explosion is unparalleled. If harnessed correctly, it could expedite the release of vital gases, jump-starting the terraforming process in ways previously thought impossible, potentially creating a positive feedback loop that would make the transformation of a dead world into a verdant, thriving one all but inevitable. However, the precision required for such detonations is immense. We must ensure that the explosions are controlled to avoid catastrophic outcomes and to maximize the beneficial effects on the planet's atmosphere. Using thermonuclear explosions for planetary terraforming is a daring and speculative strategy. Yet, with careful planning and technological advancements, it could become a pivotal step in humanity's quest to colonize new worlds. That is, if it works. Terraforming Mars and similar planets presents humanity with an incredible opportunity: the creation of a second habitable world. Imagine a future where humans thrive on multiple planets, ensuring the survival and expansion of our species. The benefits would be profound. A second habitable planet could alleviate the pressures of overpopulation on Earth and provide a new frontier for exploration and innovation. It would also offer a unique laboratory for scientific research, allowing us to study new ecosystems and the long-term effects of terraforming. Terraforming offers an unprecedented opportunity to advance our understanding of planetary science and ecology. By creating a new environment, we can conduct experiments and gather data that would be impossible on Earth. However, the use of thermonuclear explosions raises significant environmental concerns. There is the danger of radiation contamination and the possibility of triggering unforeseen disasters, the long-term ramifications of which we could not possibly know. Far from terraforming, we could make planets uninhabitable. Ethical considerations also come to the forefront. Is it right to alter another planet, potentially destroying any existing ecosystems? What if we drive an alien species to extinction prior to its discovery? The feasibility of using nuclear technology for terraforming is still highly speculative. While the theoretical benefits are substantial, the practical implementation would require unprecedented precision and caution. International cooperation and strict regulations would be essential to ensure that such projects are conducted responsibly. Carrying nuclear weapons into outer space is fraught with dangers, and the potential for unintended consequences would be a major concern. Perhaps there are other ways we could transform otherwise lifeless planets. While the idea of using thermonuclear explosions to terraform Mars is bold and intriguing, it's not the only approach on the table. One such method involves the emission of greenhouse gases. By releasing powerful greenhouse gases like methane and carbon dioxide, we could trap more heat in Mars's atmosphere, gradually warming the planet. Greenhouse gas emissions are a more controlled approach compared to nuclear detonations. They allow for incremental adjustments to the planet's climate, reducing the risk of catastrophic failures. Another intriguing idea is the use of orbital mirrors. These gigantic mirrors would reflect sunlight onto specific regions of Mars, increasing surface temperatures and potentially melting ice reserves to create liquid water. Orbital mirrors are an elegant solution, leveraging existing solar energy to warm the planet. However, they require significant resources and precise control to avoid overheating or damaging the surface. And then there is microbial seeding, representing a biological approach. By introducing specially engineered microorganisms, we could trigger chemical reactions that produce oxygen and other essential gases, gradually transforming Mars's atmosphere. Microbial seeding is a slow but natural method. It mirrors the processes that occurred on early Earth, potentially creating a sustainable ecosystem over time. But this strategy requires patience and careful monitoring to ensure the microbes thrive. Each of these methods comes with its own set of advantages and challenges. Greenhouse gas emissions and orbital mirrors offer quicker results but demand substantial technological investments and precise execution. Microbial seeding, while more gradual, provides a natural progression towards habitability, but requires long-term commitment and patience. Thermonuclear explosions could expedite the process, releasing gases quickly and potentially warming the planet faster. However, the risks are significantly higher, including radiation contamination and unpredictable environmental impacts. The path to terraforming Mars is multifaceted, involving diverse strategies and careful consideration. By exploring every alternative, we can find the most viable way to transform Mars into a new home for humanity in the shortest amount of time. Provided, of course, that we do not make our own planet unlivable before such a transformation can take place. As we look to the future of space exploration, the vision of terraforming Mars and other planets holds a central place in humanity's cosmic expansion. Transforming these barren worlds into habitable environments could pave the way for new frontiers of human civilization. By establishing a foothold on Mars, we open the door to the rest of the solar system. This endeavor could lead to the colonization of the moons of Jupiter and Saturn and eventually interstellar travel. But as we contemplate these bold endeavors, we must also consider the possibility of encountering extraterrestrial life. How would extraterrestrial civilizations perceive our use of thermonuclear weapons to transform planets? These powerful detonations could be misinterpreted as hostile actions, posing a significant diplomatic, perhaps even existential challenge. Even if our intentions are purely scientific, and aimed at creating habitable environments. The sheer destructiveness of nuclear explosions could alarm alien civilizations. How would we interpret the use of thermonuclear weapons by extraterrestrials on a lifeless planet such as Mars? Would we assume that such uses are peaceful, or would we question their motives and whether they would be willing to use such weapons on us? Moreover, the possibility of inadvertently driving alien life forms to extinction on the planets we seek to terraform is a profound ethical concern. While the primary goal is to create a habitable environment for humans, even microbial life, if present, holds intrinsic value and could provide a wealth of scientific insights. Imagine if an alien species used nuclear weapons on Earth early in its development, thereby eradicating the possibility of an intelligent species such as humans emerging. Or is it possible that such a scenario did occur on Earth? In other words, is it possible that billions of years ago Earth was a lifeless planet which was terraformed by extraterrestrials, making our species, Homo sapiens, the direct result of extraterrestrial terraforming? We may never know. Thank you for watching. If you found this video insightful, don't forget to like and subscribe for more thought-provoking content. Only on Cretonium.